Hello and welcome back. We're going to look at index numbers, the CPI, and inflation. Let's start by reviewing these terms. What is an index number? You may recall from the previous lesson that index numbers are a way to compare the relative change or difference in a data set, such as the price of products. The change can be measured over time or over different geographic regions. There are different types of index numbers. One type is a measure of average relative change in data. One data point is called the base and is assigned the value of 100, meaning it represents 100%. The other figures are adjusted in proportion to the base. What is a CPI? CPI stands for Consumer Price Index. It may also be called a Producer Price Index or a Consumer Confidence Index. A CPI is an example of an index number allowing us to compare the cost of goods today to their cost in past years. The index is used by the U.S. government to track changes in the prices of many items over time. Okay, bear with me as we read through this blurby. The Bureau of Labor Statistics publishes the CPI each month. It is often used to compare the buying power of a dollar in one year as compared to another, so it compares prices over time. The CPI is a measure of the weighted average of a basket of consumer goods and services, and this basket contains about 60,000 different items, including transportation, food, medical care, housing, apparel, recreation, and education. The more this basket of goods and services costs, the less that you can purchase with $1, right? So the more that things cost, the less that your dollar goes. The CPI is one of the most frequently used in statistics for identifying periods of deflation or inflation. If the CPI is more than 100, then prices have increased compared to the base year. This means that there has been inflation since the base year. If the CPI is less than 100, then the prices have decreased compared to the base year. This is called deflation. Very commonly, we see inflation from year to year. So deflation is pretty rare, but it does happen. Here we see a table of the average annual consumer price index ranging from 1976 to 2012. And can you look at this chart and tell me which year is being used as our base year? Well, it's actually not one. They span over 3 years, and this is what they still use today. You can see it's up here. They use from 1982 to 1984 as the base. So you can even see here how close they are to 100. Nothing's exact. 1983 gets the closest. So they just say it's the range from 1982 to 1984. So that's our baseline. The CPI allows us to compare overall prices at different times. For example, to find out how much higher typical prices were in 2010 than in 1995, we compute the ratio of the CPIs for those 2 years. And we can use the shorthand CPI with a subscript of the given year. So CPI of 2010 would be the CPI in 2010. So we would say the CPI in 2010 as a ratio over the CPI in 1995. And we want to look to our chart and find the CPI in 2010 is right here, 218.1. So this would be 218.1 divided by the CPI in 1995, which is right here, 152.4. And did I mention yet that you probably want to have a calculator handy? So if you need to pause the video, go get a calculator, do these calculations right along with me. If we do this division, we end up with approximately 1.43. So how do we interpret this? Well, something that cost, we could say that something that cost $1 in 1995 would cost $1.43 in 2010. We could also say, if we look at this carefully, we could say that the cost of products increased by 43% from 1995 to 2010, so there was a 43% increase. Those are two different ways that we could talk about this. We could say there's a 43% increase, or something that cost $1 in 1995 would cost about $1.43 in 2010 if it increased at the same rate as inflation. Okay, so suppose you needed $30,000 to maintain a particular standard of living in the year 2000. How much would you have needed in 2012 to maintain the same standard of living? So what we needed in 2000 to maintain our standard of living was $30,000. If you made $30,000 in 2012, is that better or worse than 2000? That would be worse because the value of a dollar was worth less in 2012. We need more money in 2012 than we did in 2000. So how are we going to figure this out? Well, we can use that CPI again. We want to look at the CPI in 2012 and divide it by the CPI from 2000. And then what we can do is we can take that and multiply it by 30,000 to tell us what we would need in the year 2012. So the CPI in 2012 was 229.6. Divided by 2,000, the CPI was 172.2. And we want to multiply that by 30,000. And when we do that, if you do this calculation here, you get about 1.333 multiplied by 30,000, and you would get about 40,000. So to maintain that same standard of living in 2000, you would need $40,000 in 2012. So we might say that $40,000 2012 is the same as $30,000 2000. It's a little bit weird with that year 2000 because it kind of is not the way we say other years, but that's what that would mean. So if you made 30,000 in 2000, you would need to make 40,000 in 2012 to maintain that same standard of living. Next, we're going to talk about the rate of inflation. The rate of inflation refers to the relative change in the CPI from one year to the next. For example, the rate of inflation from 1978 to 1979 was the relative increase in the CPI between those 2 years. So here we go. Oh, good. We do have those values from that table. So we're looking for the relative increase. To find the relative increase, we need to have the change from those 2 years, the change from 1978 to 1979 over our reference value, which in this case would be the earlier year. So our reference value would be the CPI of 1978. So to set this up, to look for the inflation, we do the CPI of 1979 minus the CPI of 1978 and divide that by the CPI of 1978. So what numbers are we looking at? We're looking at 72.6 minus 65.2 divided by 65.2. And make sure that you're following order of operations. You want to do the subtraction first. If you do the subtraction first, you end up with 7.4. 7.4 divided by 65.2 would give us about 0.1135. If you want to convert this to a percent, you would take this and multiply it by 100. And we would see that the rate of inflation increased by about 11.35%. Does that seem like a lot or a little to you? Well, let's compare it to a different 2 years and see what it looks like compared to another set of years. So now we want to find the inflation rate from 2011 to 2012, and then we're going to compare it to what happened in the late 70s. How do we find that inflation rate? Remember, to find the inflation rate, we want to find the relative change. So we're looking for the change in CPI from 2012 minus the CPI in 2011 and divide it by the CPI of 2011. Oh, sorry, what am I writing here? 2011. So let's look at our table. The CPI, here's the two that we're looking at. So we have 229.6 minus 224.9 divided by 224.9. We want to make sure we do that subtraction first. That ends up being 4.7 divided by 224.9. And that division gives us 0.0209 approximately. If we convert that to a percent by multiplying by 100 or a price index by multiplying by 100, we would end up with 2.09%. So wait a minute. The inflation rate from 1978 to 1979 was 11.35%. So this was 11.35%. From 2011 to 2012, it was 2.09%. So that's crazy. That late 70s was crazy. It was about 4 times higher in the late 70s than it was in the early aughts. That's a big change. Okay, now we're going to look at adjusting for inflation. And here we're looking at 2 graphs. The green graph shows the price in 2012 dollars. That's everything adjusted for inflation based on a 2012 dollar. And then these were the actual prices. You can see the 2012 dollar was a lot more than the actual prices. Now let's look at adjusting for inflation. In 2008, average gasoline prices reached an all-time high of $3.30 per gallon, or nearly triple the $1.23 average price from 1990. But was the 2008 price really that much higher than the price just 18 years earlier? For a fair comparison of historical prices, we take inflation into account. We can see how typical prices in 2008 compared to typical prices in 1990 by using the ratio of the CPIs for those 2 years. So what we're looking at is we're looking at the CPI of 2008, and we're going to compare it to the CPI from 1990. And what do we have? 2008, it was 215.3 versus 1990, which was 130.7. So if we do this division, we get approximately 1.65. So goods cost 65% more in 2008 than in 1990. So what does that mean? Let's see what that means. If we see how this should have increased based on inflation, it would have been 1.23, that cost, times this inflation rate. And if we do this, we end up getting about $2.03 per gallon. So if the gasoline prices had stayed consistent with inflation, then in 2008, this should have been the cost of gas. This should have been. How does that compare to the actual cost of gas? It is way cheaper, right? That price is about half more, 50% more, a little bit more than that, than what it should have been. So were the 2008 prices grossly expensive? They kind of were. Yeah, they were much higher than they should have been because they should have only been $2.03 based on what they cost in 1990. Okay, so let's look at a formula we can use for adjusting prices for inflation. And this little part looks a little scary, but it's really not that bad. Given a price in dollars for year X, we can just call X 2005 or whatever year, which we'll call dollars in that year. So this is our $2005. Notice the dollar sign is the normal size, 2005 is a subscript. The equivalent price in dollars for another year, so let's say we want to actually look at what that should have been in 2010, so we want to look at this as a 2010 dollar, we would use this formula. The price in 2010 is equal to the price in 2005 times the CPI of 2010 over the CPI of 2005. But I just use those arbitrary years. Of course, we can use X and Y to represent that these could be any of the years that we have information on. Let's look at an example of adjusting the price for inflation. In 1987, the mean salary for Major League Baseball players was $412,000. In 2012, it was $3,440,000. We want to compare the two salaries in 2012 dollars. So this is how we represent 2012 dollars. How does the rise in baseball salaries compare with the overall rise in prices taking into account inflation? The good news is we already have our 2012 salary in 2012 dollars because that's what it was in 2012. We need to convert the 1987 salary. So do we remember how to do this? Take that the money amount from the year we're looking at, 412,000, and multiply it by the CPI of 2012 and divide it by the CPI of that given year, 1987. So on our chart, we need to find the CPI in 2012 and the CPI in 1987. This would be 412,000 times 229.6 divided by 113.6. And when we do that, we get approximately $833,000. So if the salaries increased based on the inflation, then the average baseball player in 2012 should have made $833,000. So this is I should really label this a 2012 dollar. This is what it would have been in 2012 if that's what you were making in 1987. So that's crazy because this is what the salary actually was. They more than quadrupled. That means they increased way at a much higher rate than the average the average price or cost of things. That's crazy. Let's look at one more example. According to Computer Performance Tasks, a Macintosh computer that cost $1,000 in 2012 had the computing power greater than that of a supercomputer that would have sold for $30 million in 1985. If computer prices had risen with inflation, How much would the 1985 supercomputer have cost in 2012? What does this tell us about the cost of computers? Okay. Oh boy. So we're talking about something that was $30 million in 1985. Oh boy. Okay, so we have $30 million. We want to look at that $30 million from 1985. Okay, so let's set this up. So $30 million. It's $30 million. Then we want to look at the CPI of 2012, 229.6, and divide it by the CPI of 1985, which was 107.6, excuse me. If we were to multiply this through, we would end up with $64 million. So this supercomputer that was created in 1985 in 2012 would have cost $64 million. What did a computer cost approximately in 2012? $1,000. What does this tell us about the cost of computers? Well, unlike our baseball player friends, the cost of computers has gone way, way down. They have figured out a way to make these much more affordable than what we were looking at in the mid-1980s. These have been examples of CPI and inflation. Thank you so much.